Okay, so here at the top, we have a reminder again that an exponent is the number of times a base is multiplied by itself, and that a base can be a number, a variable, or both. We are learning 3 rules today. They are the quotient rule, the negative exponent rule, and the zero exponent rule. So we'll start with the quotient rule. Quotient rules have to do with division. So quotient is the answer to a division problem. So right here we've got x to the 5th over x to the 3rd. We are going to expand this out just like we expanded out yesterday's problems. So x to the 5th means x times x times x times x times x. So I should have 5 of those on top. X to the 3rd means x times x times x. So I should have 3 on bottom. When we have a problem that is completely multiplication on top of a fraction and completely division on top of a fraction, we can cancel things out. X over x equals 1, so that's why we're able to cancel things out. So I'm able to write here, cancel out 1, 2, 3 of my pairs of x's. Once I've canceled those out, that leaves 2 x's behind. So my answer here is x squared. Okay, the next one has m's and n's. So we've got 15m to the 3rd n to the 3rd. So on top, I'm going to put 15. And I've got 3 m's. And then I've got 3 n's. On the bottom, I've got 5mn squared. So I've got a 5. And then I have just 1 m. And then I have 2 n's. Okay, that 15 divided by 5 is going to divide out to be 3. So for normal numbers, we treat them like normal numbers. So we're going to divide these ones out like normal. 15 divided by 5 ends up being 3. Then for my m's, I can cancel 1 pair of those out, which leaves behind 2. So I've got m squared. And for my n's, I can cancel 2 pairs of those out, which leaves behind just 1 n. So it can be n or n to the 1st. Okay. With quotients, with division, when we divide powers with the same base, we had 5 and 3, we ended up with 2. For m's, we had 3 and 1, we ended up with 2. 3 and 2, we end up with 1. What operation are we doing with our exponents there? Subtracting. So to divide powers with the same base, we simply subtract the exponents. Okay, somebody's music is way too loud. Turn it down. If it's the person by you, please help them figure out that their music's way too loud. Is that you? What? Is that your music that's really loud? Okay. Do I need to stand up and walk around and figure out who it is? I still hear it. Okay, let me pause this video. Okay, I'm going to continue this. We are now going to use the quotient rule to simplify out this next expression. So we just learned that we can subtract our exponents. So this next one, we've got x to the 3rd over x to the 8th. So we're going to do x. We're going to do this 3rd power minus this 8th power. What is 3 minus 8? Close. negative 5. So this is x to the negative 5th, which is kind of wonky. We now have a negative exponent. We do not want negative exponents. So I'm going to show you by expanding this how we can make it so that we don't have negative exponents. So x to the third over x to the 8th. If we were to expand out x to the third, that would be 3 of these. 1, 2, 3. And then if we were to expand out x to the 8th, we would have 8 of them. 3, 4, 5, 6, 7, 8. Okay, we can now cancel out 3 of our pairs of x's. We can cancel out 1, 2, 3 pairs. What do we have left on top? Nothing. When we have nothing in a fraction, we do not want to put a 0 there because 0 divided by anything is 0. We want to put something there as a placeholder, though, so we want to put a 1. So we're going to put a 1 on top, and then we've got x to the 5th on bottom. So the purpose of this example was for you guys to see that x to the negative 5th and 1 over x to the 5th are the same thing. Those are equal to each other. So if you have a negative exponent, and it's in the top of a fraction, or if it's not a fraction, you can move it down to the bottom of a fraction. If you have a negative exponent that is on the bottom of a fraction, you can move it up to the top of a fraction. So it goes both directions. It can move from the top to the bottom and become positive. It can move from the bottom to the top and become positive. So I like to just think, move it across the fraction bar, make the exponent positive. That's all I think about. Okay, any questions right now? Okay, so what we've learned so far, quotient rule, subtract your exponents. Negative exponent rule, move them across the fraction bar and make them positive. We've got one more rule, which is probably the most fun one. It is the 0 exponent rule. Okay, so right here I have it set up again for us to use the quotient rule to simplify. If I were to use the quotient rule to simplify this, I would do 4 minus 4, which is 0. So this would give me x to the power of 0. If I were to expand it to simplify it, I would have x to the 4th, so I would have 4 x's on top. And I've got x to the 4th on bottom, so I've got 4 x's on bottom. What can I cancel out here? All of them. So if I cancel out everything, just like with the last one, that I wanted a placeholder 1, I want a placeholder 1 right here. So our 0 exponent rule tells us that everything raised to the power of 0 equals 1. Because everything would cancel out based on that quotient rule. So anything raised to the 0th power is 1. So that's why it's kind of nice, is because a lot of times at the end of the problem, instead of doing the whole problem, you can just write down 1. All right. We've got 8. We've got 8 examples here of different things that you guys are going to see on your assignment, and you guys have the rest of the class to work on this assignment and your other one. So x to the 14th over x to the 5th. I am dividing, so I want to use the quotient rule, and I want to subtract my exponents. So I'm going to do 14 minus 5, and that is going to give me x to the 9th power. Okay, the next one, 8 into the negative 7th. The 8 is going to stay where it is. So the 8 stays on the top of the fraction. The into the negative 7th moves to a new bottom of the fraction, and it becomes into the positive 7th. Okay, this next one, we've got 4a to the 7th, so they get to stay where they are. And then the b to the negative 4th is going to move up to the top of the fraction. So my 4a to the 7th, I'm just going to rewrite it. B to the 4th would come up to the same level and now be a positive exponent. I could put that all over 1 if I wanted to, but now that there's nothing on the bottom of a fraction, it doesn't need to be. All right, the next two are super similar. What is different about the next two?
One has parentheses.
Yeah, one has parentheses. So this first one here, the only thing being taken to the 0th power is the x. So if the only thing being taken to the 0th power is the x, then the 5 is still there and is still a normal 5. So this problem, the 5 would still be a 5, x to the 0th would be 1, so we would do 5 times 1, which equals 5 would be my final answer here. Okay, for 5x to the 0th, everything's being taken to the 0th power, so that 5 is also being taken to the 0th power. So since everything's being taken to the 0th power, everything just boils down to 1. Okay, we got one more, and then we have somewhere we kind of combine some stuff. So 12x to the negative 8th, y to the 11th. The only things that move are the things with negative exponents. The only thing that's going to move is this x to the negative 8th will move down. So the 12 and the y to the 11th will stay on top, and then the x to the 8th will now be on bottom. That arrow kind of got in my way. I'll draw an arrow here of this one going down. All right. Next one we've got some coefficients that we're going to deal with like normal numbers. And then we also have some j's and some k's. I am going to put an imaginary 1 on this j. The first right there. So 4 over 12, we cannot do 4 divided by 12. So we can think of it two ways. We can reduce our fraction. 4 divided by 12, we can divide those both by 4. It's going to become 1/3. Or we can think about doing the bottom divided by the top. 12 divided by 4 is 3. That 3 ends up on bottom. So we have 1/3 or just a 3 on bottom. Then j squared and j to the first, 2 minus 1 is 1. And then k to the 7th, k to the 9th, 7 minus 9 is negative 2. From there, because we don't want any negative exponents in our answers, we do need to move that k to the negative 2nd back down. So the only thing that's on top is the j or the 1j, but I'm not going to write the 1. So I'm just going to write j on top, and on bottom it's going to be 3k squared. I want to show you another way you could have done this. If you are trying to do quotient rule and you see that you're going to get a negative exponent, you can do it all in one step. And instead of doing 7 minus 9 and putting negative 2 on top, you can do 9 minus 7 and put positive 2 on bottom. So you can think of it as like an upside down quotient rule. So if you do top minus bottom, the answer goes on top. If you do bottom minus top, the answer goes on bottom. Okay, one last one. This one's a little bit simpler. 10 over 2 divides out to be 5. My m's 7 minus 1 is 6. And then my n's 14 minus 12 is 2. Okay, any questions right now? Okay, I'm going to stop this recording.